Do you have any confusion? Hello? I can't listen you. Sorry, I can't hear you. Hello? Can you hear me? You can reply on the chat if you can hear me. Okay, if you have any question, then you may write. I will keep an eye over your chat, okay? Uh, you may fix it if you can. It's up to you. So, now next we start that how can we find out, I'm going to clear it, okay? Yes, of course. This is called Avogadro's constant, and how do we get to know that something is containing? As we say, 1 mole. What is 1 mole? What is mole? Okay, simply we define mole. Now let's come to the point. What is mole? Mole is amount of substance. Amount of substance. Substance, I have told you that any pure thing. Okay, that can be element, that can be compound. Okay, which contains how many particles? 6.02 multiplied 10 raised to 23 number of particles. Okay, is called a mole. Okay, as we say, 1 dozen is equal to 12. The same way, 1 mole is equal to 6.02 multiplied 10 raised to 23 number of particles. Particles can be atoms if that is the element, so definitely it contains same type of atoms. And if it is the molecule, it will be containing the molecules. And if it is the, you can say that formula units, then it will be it's a compound, ionic compound, that it will be containing the formula units. But this is the constant, okay, for 1 mole, and this is called Avogadro's number. 6.02 multiplied 10 raised to 23 is called Avogadro's number. Okay. And we represent it like this. That's okay, you have got it. So let's move next. That how can we find out number of moles? We know that suppose we have sodium. I have one question. Okay, question that how many moles are there in 40 gram of sodium? Okay, in 40 gram of sodium. So we know from the periodic table, we'll see the mass of sodium. We know that for sodium, for Na, mole and mass. We'll see in the periodic table, they will be written like this: sodium 11 and 23. By rounding it, we'll get 23. 23 is the mass, atom mass. You can say nuclear number. Okay. So 1 mole contains 23 grams of sodium. How many grams are given here? 40 grams. Okay. What will be the number of moles by ratio method? 40 is equal to 23x. X will be equal to 40 divided by 23. So you will get some 1.73, I think, or something like this. It's not clear, but you will calculate it. Okay. So this will be the number of moles. This is by ratio method. This is by ratio method. Okay. I'm going to write it again. That you will write moles, and here you will write the mass. For example, you are told that how many moles are there in 20 gram of carbon. You write for carbon 1 mole is equal to 12 gram. It's okay. This is the standard. And if you have been given 20 gram of the mass, so what will be the number of moles? X. Cross multiplication. 12x is equal to 20, and x will be equal to 20 divided by 12. So whatever you get is the number of moles. This is called mole to mass calculation. What do we call it? Mole to mass calculation. This is the foundation, okay, on which we will study our next stoichiometry. So next thing is from mass to mole we can also find. If we know the moles, suppose you have said that how many moles, number of moles you have to find in 30 gram of aluminium. You write here, how will you get to know the molar mass of aluminium? For one mass of the mole is called, the mass for 1 mole of any substance is called molar mass, okay? So you write here mole ratio mass. You will see it's 1 mole is equal to 27. How will you get to know? You will go to periodic table, you will see it will be written here 13 and 27. Okay, I see your question. What is your question? We have to check periodic table. Yeah, of course, we have to check periodic table. Okay, for elements. But I'm going towards the compound and the molecules, then we have to find their atomic masses and molecular masses. Okay, so now let's complete it for the atoms. We are finding for the atoms. Aluminium is an atom. It's 1 mole is equal to 27 gram, and if we have been given it's 30 grams, what will be the number of moles? X. Okay, 27x is equal to 30, and x will be equal to 30 divided by 27. You will find the answer. So this is from mole to mass. If we know the mole, then we'll find the mass, and if we know the mass, okay, then we'll find the moles. 1.11. What it means? It's okay. It's okay. This is the answer. You are calculating. Mashallah. Good. That's good. Good. So next thing that this was mole to mass calculation. Next thing is mole to particles calculation. Okay, so if you are said that you have 2 mole of any substance, find out the particles. You are told even that you have 2 moles of carbon dioxide. Okay, so you write mole ratio particles. This is the simplest thing. This is the foundation, okay, for studying next. So you write here 1 mole is equal to 6.02 multiplied 10 raised to 23 particles, and if you have 2 moles, then it will be like this. X is equal to 6.02 multiplied 10 raised to 23 multiplied by 2. So you will get the number of particles. Okay, so this is all about the from moles to particles you can find out. Okay, and if you have been given the particles, suppose you have been given 6.02 multiplied 10 raised 40, you have particles, find out the moles of carbon dioxide. So you write mole ratio of particles. Okay, 1 mole is always equal to 6.02 multiplied 10 raised to 23. So if you have this much number of particles, what will be the number of moles? X. Okay, 6.02 multiplied 10 raised to 23 x equal to 6.02 return is 40, and x will be equal to 6.02 multiplied 10 raised 40 divided by 6.02 multiplied 10 raised to 23. Okay, it's multiplying here, it will be divided here. Okay, on next step. So in this way you will get the number of particles. If I'm teaching you quickly, then you may stop me. If you have any issue, if you have any problem, you can text me. Okay, because I can't hear you. So this is also called mole to particles. Okay, you can find the from moles to mass, and in the same way we can find the mole to particles. Third thing that we have to learn is the mole to volume ratio. Okay, from one mole to volume, but this is for gases. Okay, I'm going to erase it. So next is mole. Yes, your question. What's okay? Got it. Good. Mole to. You can say the next is mole to volume. Okay. So if you must know that there is one term that is called molar volume. Do you know what is molar volume? 1 mole of. Okay. I'm waiting for your answer, so that I may have an idea about your concepts, how much you understand. I'm waiting. It's okay. Okay. No issue. Molar volume, the volume for 1 mole of gas. This is always for gases. This is always for gases. 1 mole of gas. Okay. Yes. You need to recall your concepts, but no problem. Inshallah, we'll do it. 1 mole of gases, of any gas. Okay, of any gas contains 24 dm cube of volume. Okay, at RTP. Do you know what is RTP? Room temperature and pressure. Okay, it's standard temperature pressure. So, or you can say in some boards it is called STP, but this is RTP. Okay, so 1 mole of any gas. If you are said that what is the volume of 3 mole of hydrogen gas, you know that 1 mole is equal to 24 dm cube and 3 mole is equal to x. Okay, quite easy. It can be in other way, means if someone says that find out that you have 60 dm cube. Okay, and what is number of moles? Good. Okay, I've seen your answer. So what will you do? Mole and the 60 dm cube. So you have the volume. Okay, that is 60 dm cube, and you having the moles. So mole ratio volume. So 1 mole is equal to 24, and 60 will be equal to how many moles? Okay, 24x equal to 60. X is equal to 60 divided by 24. Yes, 0.4. Good. No, I don't. 0.4. Something else is there. Okay. 2.5. Good. Yes, it is 2.5 moles. So these are three things. First is these are called molar calculation. This is the I think you are studying the book of Matter. Yes. Okay. If you are studying that book, okay. Uh, so you have this thing, what we call it, that three. It's in chapter number 8. You have three things: that mole to mass. Second is mole to particles. Third thing is mole to volume. So you have understood these three things. Now let's move towards the stoichiometry, because this is the basic thing that you need to know about it. Okay, that's okay. All the books are same, no issue. All the concepts are same. Okay, no issue. Okay. Um, so now we are going to start next thing, that stoichiometry. Now we bring all this calculation from where we find from mole to mass, we find from mole to volume, we find from mole to number of particles. All these calculations are not dependent upon this that description. When we bring them for the balanced chemical equation, then it is called stoichiometry. Remember it. First, what we have studied till now, those are called molar calculations. Okay. Now, what is stoichiometry? Stoichiometry, the main thing of stoichiometry is balanced chemical equation, and that is the standard. Okay, we'll practice it from the past papers. Okay, so now we need to know what is stoichiometry. I'm going to, when we bring the balanced chemical equation, then it is called stoichiometry. Okay, the quantitative relationship, quantitative, which can be measured, okay, which can be quantified, which can be calculated, relationship between reactants and products, sorry, in a balanced chemical equation. Okay, you must have balanced chemical equation. Then you can find the, if you know the moles of one reactants, then you find the moles of other reactant, or you will find the moles of, from the moles of reactants to the mole of products. Okay, by the ratio method, which you have already studied. Okay, so these things are very important. So here we are going to discuss. Suppose I write here, I write here one. So you have H2 plus O2 give rise to H2O. Let's balance it. Here we have two hydrogen. We have two hydrogen. It's okay. We have two oxygen, but here is one oxygen. To balance it, I just have to change the starting moles. I write here two. So oxygen are two, but hydrogen have been doubled. To balance the hydrogen, I write here two. So from this is a balanced chemical equation. Okay. From this equation, we know that 2 moles of hydrogen and 1 mole of oxygen react to form 2 moles of, okay, water. If someone says that you have 12 mole of hydrogen and excess of oxygen, oxygen is not limiting. Okay, it's not going to finish. We have an excess. Okay, so what will be the amount of moles of the water produced? So by ratio method, hydrogen ratio, water. Balanced chemical equation, you will find that 2 moles of hydrogen will form 2 moles of water. Am I right? 2 moles of hydrogen will form 2 moles of water in the balanced chemical equation. Okay. So next, if you have 12 mole of, okay, if you have 12 mole of hydrogen, okay, so what will be the amount of water produced? X. This is called quantitative relationship between the reactants. These are called reactants, okay, and these are called products. Okay. So now the relationship between the reactants and products we can find out. Okay, and this is a quantitative. We can quantify, we can calculate. So what we get, 2x is equal to 12 multiply 2, and x will be equal to, what will be the answer? It's okay, 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 okay. 24 divided by 2 is equal to 12. Yes. Okay. Uh, I would definitely explain it once more that stoichiometry is the quantitative relationship in which from the reactants to products we can find out something. We can find, we know the mole of this, we can find the mole of this. If we know the, okay, so this is a relationship between the, in the balanced chemical equation, if we haven't given any balanced chemical equation, then we can find the number of moles by ratio method of the reactants and the products, or by comparing the reactant with the reactants, or comparing the reactants with the products, okay, in the balanced chemical equation. This is clear. Now I tell you some examples. Means I'm writing here. Suppose you have carbon, it reacts with oxygen to form carbon dioxide. So you understand it, there here is 1 mole of carbon reacts with 1 mole of oxygen molecule to form 1 mole of carbon dioxide. Okay. So there is, this is the standard. This is standard. Okay. This is standard. So if you are told that you have 12 mole of carbon dioxide, what will be the amount of carbon dioxide produced? Sorry, 12 mole of carbon, what will be the amount of carbon dioxide produced, because you have oxygen in excess. So you will compare carbon with the carbon dioxide. It's 1 mole produces 1 mole. We don't need to write here 1. Okay, make it clear. But I'm just explaining for you. Okay. So 1 mole ratio 1. 1 of carbon will produce 1 of carbon dioxide. If you have 12 mole of this, what will this? Okay, 12 mole will be produced. Okay, so means we can find by comparing reactant with the product. Now let's move towards the more genuine thing. Okay, means towards the past papers. Right. Let me share screen with you. Yes, say my exams. I think you are familiar with this thing. Okay. So here we have some questions. Which type of question it is? That's okay. Dilute hydrochloric acid. Dilute hydrochloric acid. Okay. Reacts with the sodium nitrate to form sodium chloride, water, and carbon dioxide. This is the balanced chemical equation. Okay, let's discuss it. Dilute hydrochloric acid, this is the acid, reacts with the sodium carbonate, okay, and produces what happens when they react with each other? Yes, dilute means more water, not less water. Okay, dilute means which contains the more water. Concentrated means the less water. Okay, okay. So dilute hydrochloric acid reacts with the sodium carbonate to form the solution. So you will see that 2HCl reacts with the sodium carbonate, and you will see how can we balance it. First we need to balance it. I am not writing here, I will erase it. Actually it is the not answer. You have been given HCl and you want it to react with the sodium carbonate, Na2CO3 is it's and you know that its metal with its cation will react with the anion. Okay. So it will form NaCl. Next, what will be there? H2O. What will there? Carbon dioxide. So if you see here carefully, I'm helping you to balance the equation, okay? So you will see that there are two sodium. There is one sodium. To balance it, we can't write here 2 because its formula will be changed, okay? We write here 2. When we write here 2, 2 Na have become, okay, so here is also 2 Na. So chlorine has also been doubled. To balance it, I write here 2, okay? 2 hydrogen, sorry, 2 chlorine, 2 ones are 2, 2 ones are 2. 2 sodium, 1 twos are 2 and 1 2 ones are 2. So it's balanced. But you have 2 hydrogen, 2 ones are 2. Okay, and take one oxygen from here. So H2 and this oxygen one becomes H2O and the remaining will become CO2. Okay, the remaining will be the carbon dioxide. Got it? It's okay. So actually this is not answer. I said that when this acid reacts with the sodium carbonate, okay, and sodium chloride is formed, water is formed, the gas is formed, and their symbols are given that this will be aqueous, means it is hydrochloric acid, it has been dissolved in the water. Sodium carbonate, it was also dissolved in the water. And the next thing that you get, it will be also aqueous solution. It will be liquid, and this will be gas which will be released. So I'm going to erase it to explain what is the right answer. Okay, the question number one is explain why effervescence is seen during the reaction. Do you know what is the effervescence? When you open Pepsi bottle, so some voice is produced, it means some gas is being released. Okay. What is the difference between the aqueous and dilute? Actually, aqueous means something dissolved in water. Aqueous can be dilute and can be concentrated. When there is huge amount of the water, okay, then we call it dilute. And when there is less amount of the water, then we call it concentrated. But aqueous means something dissolved in water. Aqua means water. Aquafina, you must have heard someone I used. Okay. So aquafina. So aqua means water. Okay, when something is dissolved in water, so it becomes aqueous solution. Okay, and when it contains more water, so it is dilute, and when it contains less water, it is concentrated. Gada means it contains more. Okay, it can be dilute and it can be concentrated. Short form of concentrated is like this, and dilute is like this. Okay. Explain why effervescence is seen during the reaction. Effervescence means something which is released. Okay, so effervescence means something that is released. So look here, it will be aqueous and it will be the liquid. So due to release of carbon dioxide gas, due to release of carbon dioxide gas, it will go out when they react with each other. These both are aqueous. So one aqueous is formed, one liquid is formed. They will remain in the solution, but one thing will be released as you open the Pepsi bottle. Okay, so you will find some type of the gas is going out. That is also carbon dioxide. But here carbon dioxide is produced, it goes out. Okay, so that is because of the release of carbon dioxide. Next, dilute hydrochloric acid was titrated with a sodium carbonate solution. 10 cm cube of this much concentrated hydrochloric acid were placed in the conical flask. Remember that. What is concentration? Concentration matlab कहते हैं, it means how much that contains solute. Okay, when we compare two things, then if it contains more water, we call it dilute, and if it contains less water, that we call it concentrated. But when we have to calculate and we have to tell someone that how much it has concentration, how much it has solute, okay, then we have to measure it. Okay, so here concentration means moles of the solute divided by the volume of the solution. Okay, so mole per dm cube, it is also the volume of the solution is taken in dm cube. Okay, and mole is taken in the mole. Okay, so it becomes mole per dm cube. It becomes mole per dm cube. Okay. I hope that you would have understood it. Less than 1 minute is left, so let me rearrange. uh, I rearrange meeting. Okay, so reschedule. Going to leave the meeting.